This lesson is going to be looking at how to find the value of distance and midpoint. This is the distance formula. It looks kind of complex, but it should remind you of the slope formula because it has the subscripts along with the x and the y values. So let's take a look at how to use the distance formula in order to find the distance between 2 points. So let's say we're looking at the distance between the points 5, 9 and 12, 3. First you have your formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So you now need to take your points and label them. So just like slope, you have to have your x and your y values in each ordered pair, and then they have to have the same subscripts. So I'm going to say the first ones are x1, y1, the second point is x2, y2. Then I can go ahead and I can substitute in my distance formula. So x2 we labeled as 12 minus x1, which is 5 squared, plus y2, which is 3, minus y1, which is 9 squared. So now, if we're looking at this, the square root should be the very, very last thing that you do. So with that being in mind, I'm keeping it. Then I have the order of operations to follow. So the order of operations says you do parentheses first. So we do the subtraction first because they're inside the parentheses. So 12 minus 5 is 7, and I have 7 squared. And then 3 minus 9 is negative 6, and that's also squared. Now, underneath the square root sign, I have exponents and I have addition. Exponents come first, so I have to square the numbers. So 7 squared is 49, and negative 6 squared, negative 6 times negative 6 is positive 36. Then I can add them together. So I have 49 plus 36. Right? If I'm adding 9 and 6, I get 15. Carry the 1. 4 and 3 is 7 plus 1 is 8. So I have the square root of 85. That is not a perfect square. So then that's where you have to tell me the distance is the square root of 85, but it's between 9 and 10, but it's closer to 9. So let's take a look at another way we could find the distance. Remember, the distance between these points we found was the square root of 85. So we can find the same value by graphing our points and using the Pythagorean theorem. So now that I have my graph numbered, I can plot my points. So the first point is 5, 9. So 5, 9 is here. And then my second point is 12, 3, which is here. So the segment that I'm looking at finding the distance of is this segment right here between those 2 points. So in order for me to use the Pythagorean theorem, I'd have to be able to take that segment and create a right triangle. So just like before when we found slope, my recommendation to you is to start from the top or the highest point and draw your line going straight down until you're far enough where you can go straight horizontally across and connect it to the other point. So we have to take a look at our triangle now and find the sides. So we have our right angle, which is right here. So those are my legs, and then we're missing side C, the hypotenuse. So we can now count the distance that each side of those are. So from going up, I have 1, 2, 3, 4, 5, 6. Going across, I have 1, 2, 3, 4, 5, 6, 7. So because we're missing side C, I can take the values that I know, 7 and 6, and I can square them. So 7 squared is 49, 6 squared is 36, and because it's C, I can add them together. So 9 and 6 is 15, carry the 1, 4 and 1 is 5, plus 3 is 8. And remember, the last thing is take the square root, so I get the square root of 85, which again is between 9 and 10, and it's closer to the 9. So we get the same answer either way. That way might be an easier way of calculating the distance between 2 points, but only if you have an actual grid to work with. Now let's look at midpoint. Midpoint also has a formula which is similar to distance and slope formulas, which it has the subscripts. So let's take a look at using the midpoint formula to find the midpoint. So let's look at the points 3, 5, and 5, 7. The first thing I want to do is write down my formula. So it's an ordered pair, so it's x2 plus x1 over 2 and y2 plus y1 over 2. And I want to label my points. So again, we have x1, y1, and x2, y2. And then I can go ahead and substitute in my points. So in my formula, if I substitute in my points, I have x2, which is 5, plus x1, which is 3, over 2, and then my comma, and then y2, which is 7, plus y1, which is 5, over 2. Now I have two things going on each side. I have addition and I have division. In this case, because I can't divide by an addition sign, I have to do the addition before we do the division. So I have to add first. So 5 plus 3 is 8. I can divide 8 by 2. And then 7 plus 5 is 12. And then I have 12 divided by 2. So the last step is to divide both by 2. So 8 divided by 2 is 4. And 12 divided by 2 is 6. So my midpoint is 4, 6. So let's take a look at what that would look like on the grid. There isn't necessarily a way to determine whether or not you have a midpoint on the graph besides kind of to eyeball it, but you can check if you're right. So let's take a look at graphing the points. Now that I have the grid numbered, I can graph my points. So the first point is 3, 5, and then 5, 7. And if I have a segment there, I want to be able to find the point that's the midpoint. The point that we came up with being the midpoint was 4, 6. So if I put 4, 6 on the grid, that's this point right there. And if you look at it, that is the point that is in the middle of that segment. So it looks like our calculations were correct.